Hey, this is Sheldon Primus with Utility Compliance. Welcome to the Compliance Academy. Today we'll go over how to develop a risk management program. Then that's going to be presented by me, Sheldon Primus. And I have a degree in marketing, but my master's is in public administration, and I'm also a certified occupational safety specialist. My company, Utility Compliance, provides DEP compliance and OSHA compliance for not only utilities, but I do have another entity called OSHA Compliance Help, and with OSHA Compliance Help, I do compliance for general industry and construction, and that's also OSHA and EPA DEP compliance. So today we're going to go over the risk management program, and you fall under the risk management program if you have chemicals that are on this big thing called the list of lists. And it's a big daunting name that means it's highly hazardous chemicals, and you have to have it under a certain amount of quantities. And if you have that highly hazardous chemical under a certain quantity, you have to have what's called a risk management plan. Here's a little background information. The risk management plan in 1998, the Department of Community Affairs received that delegation of having to be the regulatory body for that. The Division of Emergency Management, DEM, they're now regulate the risk management plan. And the R&P program, which is short for risk management plan, it fits well within the Department of Emergency Management, and that they have their existing emergency planning. In Florida, one of the states that I generated this course from, has the Florida State Emergency Response Commission, and that State Emergency Response Commission, CERC, they are involved in a risk management plan as well. So the program's philosophy is it emphasizes technical assistance to facilities to achieve compliance with R&P requirements to reduce occurrence of chemical accidents. So that's the program's philosophy. They want to reduce and prevent chemical releases. They want to reduce the severity and minimize the consequences of those chemical releases, and to improve coordination and communication between the regulated facility, the local emergency planning, and any other state or federal response teams and agencies. They want that communication to be very, very incorporate. It's going to make everybody know exactly what's going on. Here are the facilities that are under the R&P plan. And under the R&P plan, you see the drinking water, wastewater, food, any cold storage, because they have ammonia, which is anhydrous ammonia, which is highly dangerous, chlorine, packing, distributors, all these things that you see on that list. The military and their energy installation, and those are mostly federal facilities, are also included under the R&P program. In this video here, I do have a YouTube link, but we won't go through that. We're just going to go through the presentation. So throughout the presentation, you'll see something that says Chlorine YouTube link, but I'm going to just explain it to you without going through that. So here you see a ton cylinder of chlorine with a regulator, a gas regulator, and it's pulling out gas. It's on the top. The regulator's adjusted on the top end, and that's where your gas is. It's located in a chlorine building, so it's telling you right there location, your chemical abstract, your EPA threshold. OSHA has their own threshold, and the max quantity on site is 24,000 pounds of the chlorine in this particular site. This one was the Waxahachie River District in Palm Beach County, so your threshold may be somewhere else. But the EPA threshold is meaning if you have 2,500 pounds or more of chlorine on your facility, then you have to do a risk management plan. One of those ton cylinders, a ton is 2,000 pounds. So if you have a ton cylinder and maybe 150 cylinder, then you're actually underneath that OSHA and that EPA threshold. You're over the OSHA threshold, but you're below the EPA threshold. But the EPA is the ones that's really regulating the R&P program, not the OSHA side. Here's anhydrous ammonia. Quantity is 10,000 pounds. So if you have 10,000 pounds, that's your threshold. That's your anhydrous ammonia threshold. Here's your process for covering under the R&P program. First, your loading of your ton cylinders from the truck, how you get them off the truck, because between when they leave the manufacturer to your facility, they're under DOT. But now when they're on your facility, you have the R&P plan that kicks in, and the R&P plan wants to know how are you going to deal with the chlorine, or this is specifically talking about chlorine, but it's dealing about your chemicals. So whenever you see chlorine in this presentation, you could substitute it with your chemical. So whenever your chemical reaches your facility, either by truck or rail car, how are you going to unload it? How are you going to measure it by your scales? The storage of that chemical, what kind of areas are being stored in? How do you change those cylinders? If there is an automatic switchover procedure, you have to add that in. Chemical application procedures, that has to be added in. And that's all in your R&P plan. So here's a summary of the program. Hazard assessment, the management system, prevention program, employee participation, process safety, process hazard analysis, the procedures, and training. Those are some of the things that are going to be the first part of the program. Then after you're dealing with those major components, then you have some other byproducts as dealing with contractors, how you start up with safety review, mechanical integrity of all the parts associated with your process, hot works permit if you do any kind of hot works, welding around that facility, management of change, incident investigation, compliance audits, any trade secrets are incorporated in this standard, and then emergency response program. So all these make up your risk management plan, your process safety management plan. Those are the big components of this risk management. Here's when you need to update your program. Within 2 years after the EPA or the Department of Labor changes a regulation, you need to update your program. Before any significant changes of process happens or anything's put in place, service, new startup, any of that, prior to it going in place, you have to actually fill out the management of change and the risk management, so that your program then needs to be updated. Before any new significant changes, that's what I just spoke about. If there's an incident, once there's an incident or any kind of a compliance audit and there's any kind of significant problem, then you have to update your program. So this one is a site example of what they would look like. You see an operator there in the picture dealing with some ton cylinders all around them. There's another operator on the far end. So their facility had a maximum of 16 one-ton cylinders stored on site. 4 cylinders on one bank was kept to feed the chlorine process. This was a wastewater facility. And then they had 4 in standby mode. And then they had one stage where is full cylinders ready to go on as a backup. And then they had another section where it's empty cylinders ready to leave. So that's how this facility was set up. They had a chlorine alarm in there set up for detection of 0.9 millimeters, parts per million, and that will activate the chlorine alarm saying, okay, we have a leak, you guys should leave the room or attend to the leak. In your program, you have what's called a worst case scenario. As EPA defines it, it means on your very, very, very bad day on your facility, what is the greatest distance to a specific endpoint that you're going to affect? And this is taken into account for whatever weather event it is, or the specific density of your chemical, the wind speed, relative humidity, ambient temperature. All this takes in effect, and it's going to tell you your worst case scenario for the toxic release. And in this particular case with chlorine, the quantity of 1 ton of those cylinders, if it was to release in the neighborhood within 10 minutes, it's going to, you have to determine what that scenario is going to look like and where the mitigation is going to be. So here's a map of where our test facility is, and that little circle is it's called the circle of death as a little nomenclature for it, but it's really a circle of influence. It may not be as critical as death, but it's a circle of influence. Now, that is your worst case scenario. Another part of your risk management, you're going to have to do an alternate release scenario, meaning in the alternate release scenario, if something was going to happen, it's likely to happen. Let's say you're changing out cylinders and there is a leak and it's a short amount of time. What is going to be your affected area for an alternate release scenario? And that is not like the worst case. It's not on your very bad day. So it's going to be a different circle of influence. So as I have the slide up so you could read everything there, this is again talking about chlorine for this test facility, and the resulting release for this chlorine gas leak is going to be a release rate of 13 pounds per minute for an hour, equaling 780 pounds in this alternate release modeling. And that scenario is saying that the chlorine, you assume that the quantity of release over 60-minute duration. And now that's your new circle of influence. So you see it's a lot smaller because your endpoint is going to be just 0.1 miles, where on the other scenario here, if you notice on your top right, your endpoint is 1.3 miles of a circle of influence. So it's a big difference between your alternate release scenario and your worst case scenario. Another component is your 5-year accident history. You have to have some sort of 5-year history of accidents in your risk management plan. So you're doing a hazard assessment, and any of that history has to go in that plan. And it's the on or off site, if there's a death, an injury, evacuation, sheltering in place, property damage, environmental impact or damage, that's all in your history. So the following information should be provided for each accidental release. You gotta have the date and time, how long the release was, chemical that it was released, chlorine and hydrous ammonia, whatever that is, has to be in that plan. Your estimated quantity of the release in pounds, so you're looking for a mass quantity, and then the type of release event and its source. Also, whatever the weather conditions is at that time, if known. Impacts, on-site, off-site impact. What happened to the effect. So this is pretty much an accident investigation form at that point, where you're telling what happened in the incident, what are the contributing factors, and you break it down that way. And that's all you're gonna add is where your investigation results were at that time. Section 3 is your management system. Every good program has to have an effective management system, and this is your organization, what your responsibilities are. So who your key people are. You can have a director's operation, executive director, your chief operator, compliance. You're in a list. Who is in your management system? And then after your leadership, your management system, when you list that, you're going to determine what each person's role is. So their role together as a group is to provide the guidance to employees. If you have consultants like myself come out, someone from this team has to work with the consultant in order for us to know exactly what your system does, your history, how you handle things. So it's a close relationship. I know there's companies out there that have you input the information online, and you then just tell that company what your history was and some of your interaction. But I prefer going to the client so you know exactly what happens. You could interview people, you could talk with people, you could see the records, as opposed to having someone input the records, and it makes it a little more comprehensive. Your leadership has to be aware of relative success or failures of the program, take whatever actions needed to correct the problems. You have to have some system to hold subordinates responsible if there is some sort of non-competence issue. And that, if you're under OSHA, OSHA looks for that. But if you're not under OSHA and you're not an OSHA state, your federal regulators are going to look for that too when they inspect your plan, because that comes under a federal guidelines. And we could have a state inspector, but definitely the federal inspectors are going to look for that. On your leadership guide, you're also supposed to provide adequate time and resources, and that adequate time and resources are the people who are the leadership. You can't just put this in a back burner and say, okay, here's your leadership role in the safety and the risk management plan, and then leave them to be. You actually have to go out there. You're going to have to implement some of these things. You're going to have to instruct the employees of the hazards and the releases. And that's, overall the leadership responsibility. And there needs to be some finances behind it. And so you don't find a deficiency and then you can't pay for whatever it takes to remediate the problem. And then you could arrange for the investigations and everything at that time. Okay, the bottom slide also is important, where that bottom bullet says, ensure that the contracts for work at the plant asserts the contractor's responsibility to help prevent chemical releases. So the contractors now also bear some responsibility in this plan if you have contractors on your facility. I am going to put all these up at the same time, so excuse my animation here, but so you could see it and read it while I'm talking to you about it. Here's the employees' responsibilities. Employees have to follow the procedures, keep the work area looking good, make sure that all the controls are operable, make sure that everything is maintained, record any accidents, any near misses, so that you can have some sort of history of incidents and you don't get a non-compliance for recording an accident if you didn't know about it, and somehow it gets around to the regulator that comes by and says, oh yeah, we had an accident like this 4 years ago, and you are trying to figure out, well, I don't have paperwork on that accident 4 years ago. Well, that's where you need a system for reporting these accidents. Near misses, have to have that reported. Report any chemical releases and incidents that occur and results in a release. So those things have to be in there. As a note before we go on, and I do this in all my videos, I forgot to mention, I'm doing this from my home office as opposed to a sound stage or a studio. So you will get some background noise. You may hear my aggressive tear at your leg Yorkie poo, which is a massive 6.3 pounds. So he's all bark, no bite. But you may get that background noise from time to time. So don't worry about that. I do all my trainings informal. If I do a face-to-face training at your facility, so I'm the exact same way. I do that nice and informal. We're all professionals out there, and everything is not perfect and squeaky clean. So I do want to let you know what if you do hear some background noise, that's what it's involved. And so go moving on. Section 4.1 is a reference to section breakdown of the risk management plan, and that's the employee participation plan. And this is what you'll have in that. I'm going to put them all up at the same time for you. Okay, back on. The employee participation plan. You're going to have them involved in this, and that's the best way the system's going to run. First, management's involved, and then you have to have employee buy-in. So the Plant Safety Review Committee is a committee that is going to be involved from different sectors to help with this R&P, and they're going to do your hazard analysis. You're going to have production meetings, plant inspections with some record keeping, and that's how your employees are going to be involved in this. Here's what the actual Plant Safety Review Committee is going to do. They're going to be members, same thing as if you have a regular safety group that meets periodically for inspections and analysis. They're going out there with a focus that we want to keep this process not only working well, but safe for not only our employees, but the general public that is going to be close to our circle of influence. So they have a responsibility, a moralistic responsibility, a humanistic responsibility to make sure that the process is working safe. All the current employees that receive the initial risk management training and orientation, this also counts as an annual right to know training. So most states are the right to know, and OSHA has a right to know policy or procedure where if you are dealing with chemicals, you deserve to know what can happen to you if there's a release or if there's an exposure, and that's what's known as the right to know. Here's a little video of a risk management team, and that's on YouTube, but we won't go over the YouTubes. I do have from time to time in my slide presentations YouTubes, and I just basically go over that if I can't actually show it to you. And I prefer this time not to do the YouTubes because I want to make sure this training in the Compliance Academy, I'm reaching out to you and you're hearing my vision as opposed to something that's online. I'll put this up so you can read through it while we talk it over. In your production meetings, make sure that they're organized. Get your paperwork all set in your production meetings. Someone has to take notes so you know what happened, who's assigned things. And I like to do these where if you find a deficiency, you're going to assign it to a specific person. You're going to give that person a time frame. Let them interact with you, saying, "Oh, that's a little too loose. I can't. I could do this in a quicker time frame." Or they'll say, "Well, I'm swamped right now. Can you extend it a little bit more?" And you come to a consensus. You get buy-in. Now that person knows, okay, I need to fix this chlorine cylinder, or I need to fix this anhydrous ammonia whip, or whatever it is within this time period. And they have buy-in and they have accountability at that point. So that's what you're going to do through these meetings. You could do them at least semi-annual, but it has to be in some regular frequency. And this isn't something that you pass on saying, we don't have the time to do it right now. You gotta fit it in. That's part of your program. If you're gonna have these chemicals on your site, you need to do this to make sure that you have it as part of your program. Have a good agenda and stick to it. Someone move the meetings along. Have copies of the meeting minutes. Email them to everybody when they're done, and get your minutes lined up so everyone knows what happens. Your review committee is going to do your plant inspections. They'll go out there, they're going to find any kind of deficiencies, and they're going to see, okay, we need to work on this, we'll work on that, and that's all through a plant tour. Do it all together. You can make it part of your meeting, the beginning of the meeting or the end of the meeting, but it makes more sense if it's regular. I like it in the beginning of the meeting because you can talk about deficiencies right there and handle it before the end of the meeting. Need some good record keeping. That's going to be either your safety and compliance officer or the lead of that program. They're going to have to keep the minutes, they're going to keep the agendas, the training programs, the attendance sheets, the actual risk management plan, and the process safety manuals. Everything is going to be kept. That person that is the compliance officer or risk management head, whoever is doing it. Process safety information. You've got a couple of regulation. The EPA is in Title 40 of the Code of Federal Regulation, which is CFR, Code of Federal Regulation, and under Part 68, that's the EPA. Anytime you see 29, that Title 29 means it's Department of Labor, and the Code of Federal Regulation for Department of Labor is 29, and it's 1910 rules, which is general industry standards, and that's your process safety management. So that's where you're getting this information from. Talk a little bit about your hazards. Chlorine hazards. Your atomic number is 17, is yellow greenish gas, big pungent odor, so if you smell it, you know it. And in industrial settings, it's a lot more than the smell of bleach. It's soluble in water. That's why everybody uses it for disinfection so well, because it's water soluble. And it's the most common of the 4 halogens that's among the chemically reactive of all the elements. If you see the 1017, that's your DOT labeling. The DOT labeling is going to change with the new globally hazard GHS system, globally harmonized system for classification and labeling chemicals. And that's GHS is going to change that hazard symbol from what you're seeing there. But the atomic number of chlorine 17, so that's why the DOT designation says 1017. Chlorine. Incompatibilities. It's stable, but it's a strong oxidizer. It can lead to fire and explosion when it comes in contact with oil, gas, turpentine, either ammonia or hydrocarbons, finely divided metals, and acetylene. Chlorine should not be allowed to come in contact with alkalines, reducing agents, organic matters. Moist chlorine is highly corrosive to metals, so you see a plant that has a lot of corrosion next to their gas chlorine, and then that's what you're seeing there is the corrosivity from the chlorine. I'll leave this up for you because there's a lot of small writing, and this is all the hazards associated with chemicals. With the chlorine, and we're going to we'll talk about anhydrous ammonia next, and we'll talk about sulfur dioxide. But there's several other chemicals on the list of lists, so I couldn't talk about them all, but I just picked the big ones that you'll see in utilities and manufacturing. Your federal exposure limits is 1 part per million, and that's from your NIOSH, National Institute of Occupational Safety and Health, and they recommend a ceiling limit of 5 parts per million for a 15-minute sampling period, meaning you shouldn't go beyond 5 part per million of chlorine exposure within a 15-minute cycle, or else it'll be a health hazard to you. The NIOSH limits, it's based on preventing irritation of your skin, your eyes, your respiratory tract, and your standard threshold elevation limit, standard threshold exposure limit of 1 part per million, and your IDLH is your immediate danger to life and health level is 10 parts per million. So once you hit that category, you definitely have a big issue. A lot of small writing, so I'm going to leave this up to you so you can check it out. But the small writing means look at all these hazards at these different milligrams per liter or parts per million, same thing, at these concentrations. So 10 you'll see is the NIOSH IDLH. So if you have anything above 10, you're going to really have some potential for high impact hazards and reactions. If you get 1,000 ppm, now you're dealing with dangerous to your life after a few inhalations. And at that point, it's probably a tanker car full of chlorine that is having an issue. Some other local effects and symptoms of chlorine: reacts with your body moisture. Chlorine, if it gets on you and you have any kind of body moisture on you, it's the gas chlorine is going to bond with the water on you, and it's going to create hydrochloric acid, and that is where you're going to get burnt. And if it's in your lungs, now you've got chlorine in your lungs mixing with water and hydrochloric acid in your lungs. That's going to be a big problem, and that's local. Now, when you get to a systemic level with high concentrations, you could asphyxiate yourself and die. And so those are the levels you want to stay away from. You can have some acute respiratory disorders. Coughing is at any level of the chlorine. And then here are some of the other considerations with chlorine. That's a very dangerous chemical. So you should have a process safety analysis on there, a hazard analysis. I'm just going to put these up at one time so you guys can see all the different hazards that you have associated with the chlorine. And now, before we go into the anhydrous ammonia section, we're going to take a little break. So that's just me taking myself a little break, not like you're going to do anything, but if you can, go ahead, take your break. And then come back and do video 2. And then we'll go over the anhydrous ammonia, we'll go over the sulfur dioxide, and then we'll continue on with the other portions of the risk management plan and the risk management program. So thank you, and I'll see you back in just a few.